Let us perform an activity, activity 6.2, in order to understand the conditions necessary for combustion. Take a candle, light it and fix it on a table. Put a glass chimney over the candle and rest it on wooden lugs in such a way that air can enter the chimney. We see that candle remains lighted. Remove the blocks and let the chimney rest on the table. We see that flame flickers and produce smoke. Now put a glass plate over the chimney. We see that flame goes off because air is not available. This activity shows that air is essential to burn a fuel at its ignition temperature. Activity 6.3. Place a piece of burning wood or a charcoal on an iron plate or a tawa. Cover it with a glass jar or a tumbler or a transparent plastic jar. Observe what happens. Does charcoal stop burning after some time? Can you think of the reason why it stops burning? We observe that the piece of burning of wood gets extinguished after some time because the supply of oxygen has been stopped. By this activity, we can conclude that oxygen is essential to support the process of combustion. Conditions necessary for combustion are presence of the combustible substances, presence of a supporter of oxygen, and heating the combustible substances to its ignition temperature. You must have had an experience of burning a piece of paper. Does it burn when a burning matchstick is brought near it? Yes, it burns. Can you burn a piece of wood by bringing a lighted matchstick near it? No, we cannot. We have to use paper or kerosene oil to start fire in wood or coal. Why? Because the ignition temperature is higher than that of the paper, or otherwise we can say it doesn't reach its ignition temperature. The history of the matchstick. The history of the matchstick is very old. More than 5,000 years ago, small pieces of pine wood dipped in sulfur were used as matches in ancient Egypt. The modern safety match was developed only about 200 years ago. A mixture of antimony trisulfide, potassium chlorate, and white phosphorus with some glue and starch was applied on the head of a match made of suitable wood. When struck against a rough surface, white phosphorus got ignited due to the heat of friction. This started the combustion of the match. However, white phosphorus proved to be dangerous both for the workers involved in the manufacturing of matches and for the users. These days, the head of the safety match contains only antimony trisulfide and potassium chlorate. The rubbing surface has powdered glass and a little red phosphorus. When the match is struck against the rubbing surface, some red phosphorus gets converted into white phosphorus. This immediately reacts with potassium chlorate in the matchstick head to produce enough heat to ignite antimony trisulfide and start the combustion.